Step outside on a clear night, away from city lights. Look up. The sky is dark, dotted with stars, yes, but mostly empty. Black space between faint points of light. Now consider this. The universe contains an estimated 2 trillion galaxies. Each galaxy holds hundreds of billions of stars. If you drew a line outward in any direction, the math suggests it should eventually hit the surface of a star. The sky, by that logic, should not be dark at all. It should blaze, uniformly bright, wall-to-wall light in every direction. At first glance, it seems unremarkable, but there's more going on here than it appears. In this video, we explore why the night sky is dark, how the universe permits it, and what problem of physics and time it was designed, or rather forced, to solve. To understand the dark night sky, it helps to first look at a fundamental constraint: the speed of light. Light travels fast, but not infinitely fast. It moves at roughly 300,000 kilometers per second. That means when you look at a distant star, you're not seeing it as it is now. You're seeing it as it was when that light left, thousands, millions, sometimes billions of years ago. Distance becomes delay, and that delay turns out to be everything. The universe has a finite age. Current evidence places it at approximately 13.8 billion years old. That means light from objects farther than 13.8 billion light-years away has simply not had enough time to reach us. There's a boundary, called the observable universe, beyond which no light has arrived yet. No matter how many stars exist beyond that boundary, their light is still in transit. It has not gotten here. The sky is dark in those directions, not because the universe is empty, but because we're too early in its history to receive that light. That leads to a second constraint. Even within the observable universe, space is expanding. The universe is not just big, it's actively getting bigger. Galaxies are moving away from us, and the light they emit gets stretched as it travels through that expanding space. Wavelengths lengthen. Light that starts as visible shifts toward the infrared, and eventually into frequencies the human eye cannot detect. This is called redshift. Stars and galaxies contribute energy to the universe constantly, but by the time much of it reaches us, it has shifted out of the visible spectrum entirely. Which brings us to the final piece. Stars do not live forever. The universe is old enough that entire generations of stars have formed, burned, and died. The night sky is not a static backdrop. It's a snapshot of a changing system. Many of the sources that might have contributed light no longer exist as active stars. Their contribution has ended. The sky reflects not just the current state of the cosmos, but its history. And that history includes a great deal of darkness. The dark night sky is not a mystery that reveals emptiness. It's a product of age, speed, and the geometry of expanding space. The universe may be filled with stars, but we're only ever seeing a fraction of them. The ones close enough, young enough, and bright enough for their light to reach us in visible form. It's a strange kind of quiet. Not absence, but delay. Thanks for spending this time here. I hope this explanation added a little clarity.